All right, let's talk about Excel. I mean, if you've ever even looked at data, you've probably used it. It's just the default, right? The universal language of rows and columns. But today, we're not doing a simple how-to. No, we're going to explore what it really means to use Excel for data analysis, the good parts, the bad parts, and a surprising truth about where the real danger is. So let's pull back the curtain on the world's most popular data tool.
You know, this quote from a Reddit thread just hits the nail on the head. It doesn't matter how fancier your tools get, Python, R, whatever. At some point, that final report, that quick summary, it almost always ends up in a spreadsheet. It's kind of the great equalizer in the data world, isn't it? And that leads us to the big question we're tackling today. If everything lands in Excel anyway, is it really the best place to start your journey into data analysis? Is it setting you up for success? Or are you just learning the basics on a tool that has some pretty serious hidden dangers? Well, let's find out.
To really understand Excel's place in all this, we need the right way to think about it. It's not some kind of specialist scalpel. Oh no, it's something way more versatile.
This idea of a Swiss Army knife is just perfect. Think about it. It can do a little bit of everything, right? Calculations, charts, some basic data cleaning, and that versatility is exactly why it's such a great place to start. You get to learn the fundamental ideas of data manipulation in a place where you can actually see what you're doing, hands-on.
So how do you actually use this toolkit?
Well, here's the key. You have to stop thinking about functions as just formulas. Instead, start seeing them as tools that help you answer real-world business questions.
Okay, imagine you're working for a sports company. You don't just need a bunch of numbers, you need answers. So you ask, how many of our items are on sale right now? Boom, the count function gives you that answer directly. Or maybe, what's the average number of items we sold? There's a function for that. And here's where it gets really cool. Are these discounts actually making people buy more? Well, the Coral function can show you that relationship almost instantly. See, every function is a tool for a specific question.
But hey, getting the right answers is only half the battle. If you want to convince anybody of anything, you've got to tell a story. And that is where visualization comes in. Because the right chart can take a boring old table of numbers and turn it into something compelling.
This simple statement is so important. The chart you pick isn't just decoration. It fundamentally changes the story you're telling and the insights that your audience can actually see with their own eyes.
For example, take a look at this. With this kind of bar chart, your eye is immediately drawn to comparing the heights of the bars, right? It answers the question, which quiz had the highest score, super clearly. It's all about that direct side-by-side comparison. But what if we take the exact same data and just switch to a stacked chart? Now the story is completely different. We're not comparing individual quizzes anymore. Now we're looking at the total score and how each piece contributes to that whole. This answers a totally different question, like how much did the project contribute to student A's final grade? Same data, different chart, completely different insight.
So it's clear Excel is a fantastic Swiss Army knife to get you started. But, you know, every multi-tool has its limits. Sooner or later, you're going to need something a little more specialized.
This slide pretty much sums up what all the data pros on Reddit were saying. Excel is the undisputed king for a quick analysis and just learning the ropes, especially because you can see the data as you work on it. But the second your data gets huge, we're talking over, say, 150,000 rows, or you need to automate complicated stuff, or build these fancy interactive dashboards, well, it's time to upgrade. It's time for the big guns, like Python, SQL, or Tableau.
Okay, so we've talked about the tool's limits, but what if the biggest limitation, the biggest source of error, isn't the software at all? What if it's us? I know what you're thinking. That sounds completely ridiculous, right? Thinking is bad? This quote actually comes from a really deep dive into human error by Professor Raymond Pankow, and it's meant to be provocative because it points to a very uncomfortable truth about how our brains work when we're building things. And here is that truth in one single shocking number. Based on observed human error rates, a pretty modest spreadsheet with just 100 formulas has a greater than 99% chance of containing at least one error. Just let that sink in for a second. It's not a possibility, it's a near certainty. And this table shows you exactly why. This isn't about being sloppy or bad at your job. Even if you are an absolute rock star who is 95% accurate with every single formula you write, the errors just compound. At only 10 formulas, you already have a 40% chance of a mistake. Get to 50 formulas, and it's over 92%. The problem isn't the spreadsheet itself. It's the simple, unforgiving math of human fallibility when you do it over and over again.
Panko's research actually breaks these errors down. You have your simple slips, typos, clicking the wrong cell by accident. Then you have formula errors, where the logic inside one cell is just plain wrong. But the most dangerous ones, they're called model errors. This is when you forget a critical variable entirely. These are the errors that are so hard to find because the spreadsheet is doing exactly what you told it to. You just told it to do the wrong thing.
So, if the tool isn't the real problem, and we know that human error is pretty much inevitable, what's the solution? Well, it's not a better piece of software. It's a better way of thinking.
And this brings us to the most important takeaway of this whole thing. Mastering Excel, or really any data tool, isn't about memorizing functions. It's about developing a mindset of intense scrutiny. It's about checking your work, questioning your own assumptions, and always understanding that the potential for error is there. The discipline you have as an analyst is so much more important than the brand name on the software.
And this is what it all comes down to, really. Every single data set, every chart, every number you put out there, it tells a story. And that story is going to influence decisions. So the real challenge of data analysis isn't just about finding a story, it's having the discipline to make absolutely sure that the story you're telling is true.